Trigonometric substitutions can be quite solving integrals. Suppose I have something in the form a squared is 1 minus u squared. Then I know that cosine squared is 1 minus sine squared is a true statement. So if I can get it in this form, I can make the solution that cosine of theta is equal to the square root of a squared minus u. If I have a plus in there, square root of a squared plus u squared, no, secant squared is 1 plus tangent squared. So I can get that secant theta is equal to the square root of a plus u squared. Finally, if I have the form square root of u squared minus a squared, then I'm going to want to come to my tangent squared as secant minus 1 so that I can get that the tangent of theta is square root of u squared minus a squared. Now, there are ways to remember these. You have an integral and it's got the square root of a squared minus u squared. Then draw your triangle. U is opposite your angle. A is your hypotenuse, and of course, that is the square root of a squared minus u squared. Let u equal a sine theta. U equals sine theta, because in this case it is. And then the square root of a squared minus u squared is what? It's a cosine theta. And you restrict your domain. Now you have a square root of a squared plus u squared. Let u, it's opposite the angle. A is adjacent, and then the hypotenuse will be a squared plus u squared. You're going to make the substitute that u equals a tan theta, and you know that the square root of a squared plus u squared is a secant theta, where again you restrict your domain. And finally, for integrals involving the square root of u squared minus a squared, well, I know this is my hypotenuse, right? And you're always going to have a u sort of term opposite the angle. So this is going to be the square root of u squared minus a squared, which makes this a. And then u equals a secant theta, and you're going to make the solution the square root of u squared minus a squared is plus or minus a tan theta. Now it's plus or minus depending on whether greater than a or less than a. Now let's try one. Suppose we have dx, the integral of dx over x squared, square root of 9 minus x squared. Well, it's of the form the square root of a squared minus u squared. All right. So the first thing I want you to do is draw your rectangle. Draw your triangle. Do a much better job. Label your angle. All right. Now opposite. Let this right here equal x, and then this side right here is equal to u is equal to x in this case. Sometimes it'll be functions. It could be functions. So a in this case is root of 9 or 3. All right, so this side right here is the square root of 9 minus x squared. Now you're going to make the substitution x equals a sine theta. And a is 3. So the 3 sine theta. And dx is 3 cosine theta d theta. So I've got the x's taken, but the square root of 3 squared minus x squared, I want this to equal 3 cosine theta. All right. So now let me put this all in my integral. This becomes dx is 3 cosine theta d theta. That's the dx. Divided by x squared is 3 sine theta. And this whole thing is, now the square root of 9 minus x squared is 3 cosine theta. Now you're always going to have to do some sort of simplifying here. Those are going to cancel, left with 1/9 times the integral of d theta over sine squared. Oh my goodness, that's secant squared. So this is 1/9 the integral secant squared theta d theta. But I know that is 1/9. Now, 1 over sine is cosecant. So first thing you're going to do is the correct integral. So let me undo this. It's 1/9. The integral d theta. The integral of cosecant squared is, of course, minus cotangent plus c. But I need to get this back into my x terms. So to do, let's go back to your triangle. What is the cotangent? Well, the cotangent is square root of 9 minus x squared over x. So this is minus 1/9. Okay, this is square root of 9 minus x squared x plus c. And you can leave it this way.